Today is our first opportunity to be together. And my name is Gianluca Dianese. I am the director of the Innovation Hub IDEASFORUM. And I will just make a very quick introduction of the team of speakers who will be joining us today and guide us through the topic of the day, that is the use of FIWARE Generic enablers for the development of smart energy applications. Could you move to the next slide, please? Just a few words about what IDEASFORUM is. This will be one of our few events in English because we are based in Germany, in a city in the land of North Rhine-Westphalen, or North Rhine-Westphalia in English. And our particularity is that we are strongly focused on trying to identify how civil society and technology can better work together. So what are the ways that we can be sure technology is available, becomes relevant to people and for businesses, become used by people and businesses, and are tailored to support people and businesses in trying to pursue their needs. One other particularity of us and the way we are doing things, and probably you will hear something more about this even afterwards, is that we are definitely jumping into the open source culture. So this way of doing things, collaborating with others, sharing with others the results of our work, and actively participating to the life of the community and to the achievement of the objectives of the community. The forum will be operating as a virtual collaboration place, not only because of COVID, but also because of building and having built a network of different entities from the private sector, the public sector, academia, and so on, because we heavily and highly value digital diversity. So there are different open source programs and communities that are delivering contribution to be able to support the public sector in digital transformation. And for this reason, we want to be considering and exploiting and leveraging on the added value that all of them are bringing. And the other thing that is particular, probably not only of us, but I mean on how innovation hubs are operating, is the fact that after we've been talking about things, we want to build. We want to be sure that whatever kind of added value we've been able to build is bring into real life, is deployed, is validated, and then eventually it's scaled. If you could move to the next, please. What is also relevant is that we will be operating, as I said, with a clear focus on our foundation that are in whatever kind of sociological and economic implication of the use of technology. For sure, by approaching our various initiatives with an open mind culture that will allow us to collaborate and value the contribution of everybody. And we will have, at least at the beginning of our journey, 4 competence areas that we will be somehow trying to build together with our members, with a clear focus on what is called smart cities. So the delivery of citizen services and infrastructure services in urban environments. Smart energy, that is, I would say, the stream that is somehow coordinating within the topic that today we're kicking off. Smart mobility, that is particularly relevant not only in our area, that is one of the most congested across Germany. And then a topic that is, I would say, not new, but definitely not known enough. And this is the work being done by the European Commission through the Connecting Euro Facility digital team, with the release of the Connecting Euro Facility building blocks. There are standards, open source components, services, which are derived from the regulatory work of the Commission and are providing, I would say, a framework fully compliant with the regulation to start implementing and delivering digital services. The next slide, please. Last week, we are extremely proud of having been nominated as a FIWARE iHub. So one of the things that we will be doing is supporting the activities of the FIWARE Foundation. For sure, FIWARE is within the European panorama of different open source initiatives, one of the most relevant. And this is demonstrated by the fact that the Connecting Euro Facility program that I was mentioning before, and also the Linux Foundation for Energy program are tightly connected to the work of FIWARE, particularly when we're talking about the world of energy. Next slide, please. We have already been working with, can you move to the next? Sorry. Hello? Okay, so we've been already counting on the contribution on the number of entities. You see a few of them that are mentioned in here. And today we are honored of having as our speakers the team from the EON Research Center at the University of Aachen, the team led by Professor Monti, that you see in his video cam. We have, I would say, 3 speakers, in addition to Professor Monti, also Markus Mirz and Malileh Haghgoo, that was also on video before. And they will be providing us with a very dense, I would say 45 to 1 hour, 45 minutes to 1 hour of content, which is supposed to somehow take some, somehow a technological flavor, without the possibility to go into too many details, to try to break down the session and making it a little more interactive. We will be using Mentimeter, and in the next slide we have for you the code that you should be entering. You go to www.menti.com and type 3405523. And with this, you will be able to give us some feedback while we are proceeding with the event. So without further indulging into hearing my voice, I will leave word to Professor Monti, who will be somehow kicking off his part of the presentation. Thank you. Oh, by the way, sorry. Before we start, we would like to know from you, where are you coming from? So what exactly is the reason of your interest in what you will be hearing today, and why talking about FIWARE in smart energy is a topic that has been triggering your interest. Let's see, the voting is open. Don't be shy. So it looks like our Mentimeter is betraying us with the delay. So there is a very interesting adds-on here between university research and consulting. And let's wait another 10 seconds before calling it a day. Very good. So thank you very much. So Professor Monti, please.
So first of all, Gianluca, thank you for the kind introduction. Good afternoon, everybody. And I will start my introduction part, which is basically a bit of historical review on how FIWARE developed, and to make you aware of what is the background of this project for those of you that maybe didn't hear about it before or quite recently got in touch with FIWARE. So the overall talk will then cover the application of FIWARE in several use cases and projects in which my institute have been involved. Then we will move to talk about different perspective, still on the concept of platform, related to another family of project in which my group is involved, which has more a focus on grid operator than on the other part of the energy business. And then we look at how this thing can be put together so that we kind of integrate in a global view that fits also in other scenarios bigger than smart energy, like, for example, smart city. So if you could move to the next slide. So Future Internet was a program of the European Commission that started something like 10 years ago, and it was divided in 3 steps. The idea was, if you look at concept of platforms and we look at different sectors, there are a lot of features and functions that are common independently from the application. And then there are a lot of features, vice versa, at the same time, that are more specific of a given sector, let's say energy. So the Commission started a phase 1 running a project in which, on one hand, there was a study of the generic structure of the platform, but even more interesting, a set of projects that were looking at specific vertical and trying to define a requirement to build this view of platform. Finsony, that is the project featured here with the web page of the project at the time, was the first studies of FIWARE concept in the direction of energy. What the project did was develop an incredible list of use cases, more than 100 use cases, in which a futuristic possibility of a platform could be applied in the energy sector. And the focus was really on requirements that they were pushed to the platform generic project, so the one that at the end was already called FIWARE as a project, to make the voice of energy heard by the other sectors. So if you click one more time, then in the second phase of this initiative of the Commission, the idea was to try what was tested in the first phase and to bring it to the real life. In the energy sector, there was a project which I had the pleasure to be, for which I had the pleasure to be technical manager, called FINESC. That was taking the lesson learned from phase one and going to real life. So after only 2 years of work on phase one, in the third year, FIWARE started being a real life platform applied in a variety of use cases. If you click one more time, we can see here a map that shows the different trial sites you see spread all across Europe, covering a variety of use cases from microgrid to smart building to grid operations. And you can see also, looking around, the number of patterns involved was a very relevant large project in which we had the chance to really learn how FIWARE could be actually used in the energy sector. This was the program of the Commission. In the first step, then the Commission supported the startup to learn and try FIWARE, with the idea that then FIWARE will grow further to become something independent from the funding of the European Commission. And that took some time, but it happened. So if you click one more time, the FIWARE Foundation was then the next step that took the results of FIWARE, which basically was a catalog of these services, or call it building blocks, that define the architecture of the FIWARE platform. They were available as open source and reachable through a catalog available online, in which you could find all the information about the first two phases, also open source version of the different codes that was developed during the project. And then thanks to the foundation, this moved to be simply a website to a structured organization that manage and support FIWARE in the long range. If you click one more time, and fundamentally the idea behind the FIWARE vision was to create the condition to break the silos among different sectors. So as I mentioned in the phase one of the research part, there were already several projects in a variety of sectors. That is basically the list you see here, among which smart energy, you see that very well placed in the middle, but even completely different use cases like smart logistics, smart cities, smart farming, smart industry. And the idea is that the more we move into a digital world, the more we need to bring those sectors together and to exploit a project that goes across these different silos. So clicking one more time, and that brought us to the creation of the foundation, which is now a reality, is incorporated in Germany, but is it's a very international structure. Here you see the platinum member are basically the one that created the foundation, and they were also leader in the research activities. So Atos Engineering, Telefonica, and Orange. NEC from Japan joined later as platinum, and if I'm not wrong, also now Red Hat joined as a platinum member. Then you have a lot of gold and associate member. And what FIWARE have been doing at the very beginning as foundation is to focus on fundamentally smart city and smart industry. As mentioned before, thanks to this focus and the fact we had a foundation, things evolve and got recognized. So FIWARE, some of the blocks are now recognized by ETSI, particularly when it comes to the data model structure. And even more important, at least from a European perspective, some of the key building blocks are recognized by the Connecting European Facility, as Gianluca was mentioning before. That was the background. And just to give you an idea, clicking one more time, please, of some of the applications, I just touched on two use cases that were part of FINESC, just to give you a flavor on how this can fit. Then in the following, my assistants will get much more technical. This first example is a smart city, smart energy project in the city of Malmö that we developed in the project FINESC in cooperation with E.ON as utility. Why I mentioned this specific case? Well, in the phase two of the project, after 6 months, we were on the field running a test, and E.ON developed internally the adaptation of their platform to be part of this field test. What's the message here? Well, I wouldn't call E.ON a software house, And in 6 months, they were able to do live tests with real people in their grade, which shows that using open source standardized building blocks, we can build quickly solutions that have a commercial value. If you go to the next one, the other and last example I would like to bring from the past is the Smart Village in Denmark. Here, with a fantastic operation of our partners in Denmark, they were able to involve really the citizen in the experiment and transforming a small town in Denmark into a CO2-free, completely CO2-free operation. And again, time to market was unbelievably short thanks to the concept of platform with standard generic enabler, so the generic piece of software that go beyond the energy sector, and a bunch of domain-specific enablers supporting the energy use cases. So here, the main message is the FIWARE is now a foundation, so as a way to support, develop, and grow in an organic way. It has been proved in the real life, and it's open source, and that has been enabling very fast process in a variety of use cases. With that, next slide, please. We go to the Mentimeter before we start with the more technical part, and I will give the word after that to Markus Mirz, Dr. Mirz, one of my assistants. Let's see for the moment the result. Don't be shy and vote. We are now in a situation, okay, that's pretty cool. There are several FIWARE users in the crowd, so we had a majority of people that use FIWARE before, but still some interesting representation. People never used the software before. Good. I think this was interesting information also for our speakers coming up and presenting the application and the use cases. If you can click to the next slide, please. I will give now word to Dr. Markus Mirz to start the description of the reference architecture.
Yeah, so the majority of you already know this from the Mentimeter results, but I quickly want to summarize for the ones that don't know what it means to build a FIWARE-based project. The vision of FIWARE is to break these data silos using a standard API, NGS-ILD, and also common data models. I will show you later where you can find information on this. And apart from that, the FIWARE Foundation is actively supporting the implementation of software products that implement the standard API and the data models. And yeah, the implementations of these two parts are called context brokers, and there are many of them called Orion, Stelio, or Scorpio. The first one, I guess, was Orion. And as you can see here, the typical FIWARE project puts this context broker in the heart between the IoT agents and the services that have to use this data, so that the IoT devices can push the data in the context broker and the services can retrieve the data from the context broker. Can you go to the next slide, please? Yeah, I already mentioned data models. What FIWARE does at the moment is to build more and more domain-specific ontologies. For example, the Smart-Energy, which is not even on the slide yet, just started. And yeah, we are supporting this development as an institute. And as you can see, there is this core meta model, cross-domain ontologies, and then on top of this, extensions for each domain. Can you go to the next slide, please? What we want, so this slide basically summarizes the different contributions that that we see at the moment in the domain of energy. The first ones in bold are the ones that we are talking about. Malileh is going to talk about the use cases that we implemented with FIWARE Generic enablers for the energy domain. Then we are also working on a bridge between smart cities and smart grids. You will see in Mali's slides that most of the applications that we do are more on building level, more in the smart cities direction, I would say. Also, it's coming more and more to smart grids. But I would say that the majority is smart cities. And what we have done in projects that we are going to talk about in the third part of this presentation is how we bridge the smart grids applications that are focused on the DSO and the smart cities applications. Apart from that, we are also working on smart data models, as I mentioned. Here you can find the GitHub repository, and what we are focusing on the moment is to provide JSON LD schemas for SIM, Zaref, and IEC 61850, which are for the ones that maybe you are not all working in the power system domain. These are very common protocols used for automation and exchanging grid information in power systems. And the fourth domain that we are working in is to bring FIWARE components to the cloud, and specifically to Kubernetes, which you could say is the Kubernetes, you could summarize in one sentence, is the operating system of the cloud. So it's basically the Linux of the cloud. And we are developing this catalog of recipes to quickly set up FIWARE components in the cloud. Yeah, and this concludes the summary of the FIWARE contributions in energy. And now I think we have another question, and then it's Mali's turn to talk about the use cases. Okay, so it seems that most of you are working in smart grids or smart cities. So the following slide should be relevant for you. And hopefully the ones that don't want to work in this domain after the following slides. Yeah. Okay, so now it's Mali's turn.
Okay, hello everybody. This is Mali from Erveta. In the following minutes, I'm going to present some use cases using FIWARE. In this regard, I will introduce two existing, I can say actually almost finished research projects that are fundamentally powered by FIWARE and using this framework in different purposes. Could you please go to the next slide? I will start with the FISMAP project, a project built upon the FIWARE concept. As it is presented here, FISMAP abbreviation is FIWARE for a smart energy platform. FISMAP has been created to develop an open source cloud-based platform for smart energy. It is founded in the framework of the joint programming initiative of the ARANET Smart Grid, plus to the support of the European Union Horizon 2020. This project started in December 2017 and runs for 3 years. It will up in the November 2020. European countries are collaborating in this project. If you are interested to get more information in this regard, here is the link into the webpage of the project. I will introduce just briefly what are the use cases in this project. Could you please go to the next slide? Here is the quick overview of the project. This project contains of the 3 trial tests, which are running in Germany, Sweden, and Romania. As you can see in the figure of the left side, the main target of the German trial is the management of the automation in the MBTC or hybrid ACTC. In Sweden trial tests, we are integrating energy management system, considering the user involvement. In Romania, we are doing some monitoring and controlling of the grid, while the device is called phasor measurement unit in the abbreviation PMUs. Figure in the right side is the abstract presentation of the FIWARE platform, which must be familiar for those had already looked into the FIWARE webpage and catalog. According to this abstract model, we try to shape FISMA platform and make a pool to the integration of for the integration of the data coming from the different trials, as I already mentioned. Could you please go to the next slide? In the coming slide, I will present briefly what we have done specifically in each trial test. For example, Sweden test, trial mainly on the building energy management by involving the user in the real living lab, so-called HSC Living Lab in Chalmers University. They are integrating two sources of the information to the FISMA, apply the algorithm regarding to the building energy management. One source of the data or information is a so-called Arrow app. This is the mobile application to engage the user activities and apply a forecasting algorithm to give the compatible recommendation to the user about the energy usage. The second source of the information is about the smart grid platform, so-called EON, CESO app or platform. This is the digital connection of the consumer to the EON grid. This platform focuses on the optimization of the energy, district heating and district cooling, and electricity production. This source of information gathered and integrated to the FISMA platform, and as a service via the Arrow app, we are giving some recommendation to the user which are involved in this study. Could you please go to the next slide? The other use case which is considered in this trial test, doing some building energy monitoring, as you can see in the presented architecture, to enable the bidirectional communication secure with the TLS between the automation layer of the existing building energy management system and the FISMA platform. Two extension has been developed for building automation and control network of the BACnet and MQTT protocol of the open source gateway framework OpenMOOC. The diagram presented about 7,300 data objects delivered from 1,000 devices, which are automatically registered and scanned as a data source into the platform. To visualize, we use the Grafana. This is a kind of open source which can be used for the data visualization. We use the data as a log monitoring of the data. The Grafana is used for the presenting the log monitoring of the data in this study. Could you please go to the next slide? Second trial test in Romania. We are collecting the measurement from the PMUs and doing some visualization on data to use the information for the further analytics. Focus in this study is on the monitoring of the data from the transmission system, which are installed in the different PMU streams data from the locally estimated like the voltage, frequency, current, power, using the short measurement windows, about 40 milliseconds, and report information every 10 milliseconds. The usage of the PMU in measurement of the power system gives the opportunity to access the information about the state of the system, not only in the normal operation, but also in the critical states. In this study, PMUs are installed in the few nodes of the high voltage grid, monitoring and also connected by current and voltage instrument transformer from the substation of the power grid. Each PMU is identified by an ID and its position, which is taken via the GPS. And for this specific test case, we took 5 PMUs, and the data are gathered, visualized by the web cloud. Could you please go to the next slide? The threat field test, which has been developed in Germany, we consider the automation of the DC grid. In the field test, the visualization of data in the DC medium voltage has been taken into account. Accordingly, we gather data from the intelligent electrical devices, so-called IEDs, and send the data to the platform via the MQTT. As an outlook for this specific use case, I can say we are developing this extension to the XMPP protocol based on IEC 61850, which is a kind of standard for the substation automation to have a secure communication with the electrical world. Could you please go to the next slide? Other use case defined in the German field test is network protection, so-called service restoration. Before going to the project setup, I want to simply explain what is this scenario. In case fault happen on the electrical grid, the protection system opens the circuit breakers down, up and down of the stream of fault. On the other side, as a distributed radial, go downstream, the fault are not more energized. To find how and which normal open switch has to be closed in order to restore the power, different techniques and approaches has been developed by the researchers. This sort of algorithm called service restoration. This is the main concept of the algorithm we have been used for this setup. Could you please go to the next slide to just briefly explain what was the setup in this trial. To set up the cloud-based service restoration in the FISMA project, we modeled the medium voltage distribution grid with the RTDS, which is the real-time digital simulators, and update the status of the switches in the real time. While we are subscribing the context in the FIWARE context broker, we identified a specific constraint for the real-time data to notify or trigger service restoration, which is running as a service in the cloud infrastructure. Accordingly, if such a status is changed, broker will realize it is a kind of event and will send a notification to the service restoration. Service restoration algorithm will calculate the status of the switches, loads, and network. Afterward, it will propose a specific solution which can be used to re-energize the disconnected loads. In this test setup, we sent back the proposed solution into the RTDS as well to visualize which switches must change their own status. Therefore, the established setup has a kind of bidirectional communication, or is a closed loop communication between of the RTDS to the service restoration in the cloud infrastructure and vice versa. Could you please go to the next slide? FISMA platform in general is managing and processing the context information in a distributed system architecture. We check the feasibility of the FIWARE-powered platform in the sector coupling and integration of the new services. In each domain, we adopt the presented architecture to gather the data and analyze them via services. In general, the middle box can replicate in any other project which are going to integrate data from the different sources. We try to categorize the list of components or services we need for each trial test and end up with the presented figure. According to this figure, we need to consider a layer to interface the smart devices, and the following layer to gather or process, manage the data coming from the different sources. Finally, we need to have a package of the services, which can be a domain specific. Here we had the service restoration or kind of visualization for the stream of the data, and end up with this architecture for the inside of the FISMA project. Okay, can you please go to the next slide? Other project which intensively use the FIWARE is N5G project, is a national 5G energy hub. This is the German-founded project and planned for a decade. And in the first phase of this project, we plan to produce open source cloud platform, which is interfacing sensors and many smart devices in the cloud or edge cloud infrastructure. In the first phase of the this project, Technical University of Dresden was a partner of the Erwata University, and project started in 2018 and ended in the last month. Further information regarding to this project can be seen under the webpage of the project. Okay, the main focus of this project was related to the building energy monitoring by installing many smart devices. Could you please go? Yeah. List of the sensor and actuators are sending the stream data regarding which could be a kind of heating system, cooling system, electrical system, and so on. The data gathered and integrated in the local integrated with the local data in the edge level, and doing some monitoring and controlling in the edge level. And the process or direct stream of the data can be sent to the cloud platform for the further analytics. As you can see in the left image, the overview of the presented concept is shown. And yeah, this is the main use case in this project. Could you please go to the next slide? In general, overview of the project infrastructure presented in this slide. We identify four main layers for placing the data generated from the different data sources. We start the journey by gathering the data that must be transported to the platform. And for that specific case, we identify the transport layer indicated in the first stage, and mostly use the mentioned communication protocol to transport the data into the platform. In the next layer, we use the IoT device management. This layer is responsible to the translating of the source protocol to the destination protocol. Additionally, it's doing some kind of the device provisioning group if you want to go further in the details of the IoT and IoT concept, security, and so on. We need the other layer to process, store, and analyze the data. For that reason, we use the context broker and add some other group of the generic enabler from the FIWARE to add some analysis over the historical data and so on. The last layer, which could be a package of the energy services, are considered in the fourth layer. I can mention PID controller or visualization and some specific other services related to the energy in this package. Could you please go to the next slide? In general, according to the requirement definition and also requirement analytics of the both project, we could categorize the list of the component into main categories, like the general blocks and specific blocks. For the generic blocks, which are taken from the FIWARE catalog, if you want to just have a very core and general ideas, we will go to the place or layer where we can have the IoT management. And for that case, we use the IoT agent or IDAS. You can take it for the kind of grouping or security, or somehow adding the security in your platform and provisioning of the IoT devices. If you are thinking about the managing of the context information, then Orion LD would be a nice component. If you want to think about the further analytics over your data stream of historical data analytics can be added to your concept by taking the CreateDB and belong to the Contoblib. If you want to have a simple use case, then visualization of the data would give you some opportunity on have an overlook or analysis of the data by the Graphon or via cloud. And what we already developed as a specific blocks, I can mention Fleaser, or for the visualization of the PMU, we had developed some specific buffering methods and algorithms to gather the data in the close to the PMUs and then send them to the platform or context broker. Or I can mention the Arrow app as a mobile application in communication with the context broker and the user to somehow apply some machine learning algorithm, recommend and forecast the energy usage of the user. I think this was the last slide from my side.
Thank you, Mali. We have somehow a sort of a break now. It would be interesting if you could provide some, let's call them buzzword, which refers to the first takeaways of this batch of projects that we're leveraging on open source and FIWARE technology. So I will leave this open for a few seconds. So if you can think of anything, just type it in. So I see some interesting points here. Interoperability seems to be particularly relevant to many of you. Open source as a key driver, security, the integration of legacy systems within these new frameworks of digital energy or smart energy applications. I see also popping up complexity that definitely pertinent to a domain that is somehow building up and consolidating almost as we speak. And I would say that probably we can call it a day for this specific question and move to the next session of the presentation, where again, Professor Monti and Dr. Mirz will somehow guide us through some other example and reference projects where open source and FIWARE technology have been playing a role. So, Professor Monti.
Yeah, thank you, Gianluca. Next slide. So, as I mentioned in my introduction, now we would like to focus more on a familiar project that started from a different perspective, so specifically the perspective of distribution system operator, and then show how this fits anyway into a generic FIWARE architecture, so how you can bring things together. Here you see a set of projects funded by the European Commission. One already finished called Sonio is the first one I will discuss about, that introduced the idea of a service-oriented application to automation, which is kind of a disruptive view, as I will try to explain. And then Platona Edge Flex are two projects that inherited from Sonio. And well, OpenDI is a coordination support action currently running, which is the way I will try to then bring this overall picture also from the European perspective all together. So next slide, please. As I mentioned, Sonio is the starting point where we started working on this new idea of platform for distribution system applications. Here, among the grid operator, we focus on the one running distribution grid, which means medium and low voltage. We don't deal with transmission. Why? Because distribution grid is where all the changes right now are basically happening, because renewables are connected in medium and low voltage. The customers, which are becoming active customer or using some recent terminology, prosumers, are all connected in medium low voltage. So in Sonio, we say how we approach the automation in such a network, and in it's a kind of a infrastructure. The tradition didn't need a lot of automation, but vice versa, when we move towards a futuristic grid with high penetration renewable, will require very distributed and detailed coverage of automation to come all the way to the final customer. So we define some key pillars to build this solution. First of all, from hardware, we need to use equipment for measurement that are extremely efficient, accurate, better, but also low cost. And then when it comes to the implementation, the idea was that because we need to replicate the locality of the distribution grid, we will need to look into edge computing as a solution. And the idea to minimize the hardware in the field that is specifically for the purpose of the automation, to use the concept of cloud virtualization for the intelligence of the different parts of this infrastructure. Particularly in the project, we consider a specific implementation for this edge solution, and then looking at 5G as a way to implement. Not by chance, the coordinator of our project was Ericsson. And then, because the complexity of this infrastructure is rather significant, we also thought would be the right time to start looking at algorithm based on machine learning, particularly deep learning, to address the complexity of the systems for which building a model becomes quite of a challenge. Going to the next, and from this view came the architecture of what we call the platform system. The idea was that we start from the electrical grid, which we have a set of measurements and devices. We build a solution that, even if it inspired by 5G, is independent from the communication infrastructure. So it could be also PLC communication, fiber optics, or LTE, not necessarily 5G. But the link was at the end based on MQTT. That was the idea. The MQTT structure allows us to create an integration bus. And on this integration bus, we can plug in standard services that the DSO, distribution system operator, may use. Among those services, one that will be basically always there, two. One is the database, storing the data and the historic evolution of the system, and the visualization to give the picture in the control room. So this has been developed, demonstrated in real grids, particularly in Germany, Romania, and Ireland, proving that this modular architecture is feasible. And thanks to Docker container, we could also easily deploy it in edge solution. Next slide. Here, this architecture brought two important innovation into this market of distribution grid operator. First of all, the idea of a modular approach to solution, which is the contrary what you currently find on the market. There's very few providers that develop very monolithic solution of automation, which is not encouraging innovation in the single services, but more requesting large investment concentrated on a single provider, which is then not in favor of a rapid and continuous evolution of this concept of platform. And the second, the idea that we could even imagine that this platform will be deployed as a service. This is particularly interesting for operators which are dealing with not such a large grid, for which purchasing a large SCADA systems, as traditionally done, will be extremely expensive and a big roadblock towards the digitalization of the grid, something that we really need, and simplifying also the IT effort of the single company, because basically the grid operator could just buy the service and access the service, without big restructuring of their IT department. Going to the next. Building on that knowledge and experience, we've been evolving this platform in three directions in the following project, which is still running, called Platone. And Platone had the three elements of novelty: the possibility of a blockchain interface for the customers, so that we can both between customers and from the customer to the DSO have secure exchange of data with trust, building trust. We have the link to legacy systems so that previous investment will be not wasted, but it can also be integrated in this more modern platform, and also looking at the development of a link to market platform so that everybody could join any kind of futuristic market of energy, with particularly a focus on flexibility market, which is supposed to be the next big thing in market. And the DSO, so the grid operator in the middle, as a data facilitator that is in, let's say, an unbiased provider of data to support this overall infrastructure. Next slide, please. Still on the same, coming from Sonio, the Agile project EdgeFlex, vice versa, look at how that architecture could support a more modern view of the so-called virtual power plant. Virtual power plants are normally consider an aggregation of generation resources, particularly renewables, to be able to play on larger market. And they are typically traditionally developed as simply market instruments. So no consideration for the interaction with the grid operator. But in reality, the more we move towards a system that is based on renewables, the more will be important to provide through those distributed resources also new variety of services, which will be what we call here fast dynamic services. These fast dynamic services will be really more related to an interaction with the distribution grid operator. And then again, this means expanding the view of the Sonio platform to incorporate these new use cases. So all that three projects together show that we built a quite sophisticated ecosystems of use cases that support local operation of grids. Distribution grids are basically also the grid we have in the cities. And so also the more candidates to be affected or interested, whatever you prefer, by new interaction of verticals. And that's where we get into the FIWARE territory again. Go please to the next slide. So when we try to go beyond and try to create solutions that are not just for a single sector, here where we mentioned the project OpenDI, the DSO platform I've been discussing so far will be the red big blocks in the middle based on microservices running on a message broker on MQTT. We already mentioned that in the project Platone, we are looking at and developing the interface to legacy SCADA so that third-party systems can be part of this. But here we want to add here where we break the silos, thanks to FIWARE, thanks to the IoT agent, we can also create a link between this message broker and a generic smart city platform typically based on FIWARE. In this way, solutions which have been totally developed and thought specifically for the energy sector become a child structure that can be integrated in the bigger picture of digitalization at smart city level. And that's where you come to cover use cases, for example, such as e-mobility. Next slide, please. And here is understood this picture of energy systems. How is that fitting in the bigger picture of energy, vice versa? We saw how energy fits in the smart city. How is this work and this link to FIWARE, the way defined so far, fits in the larger view of the European Commission? The European Commission is trying to build a common view, starting from the customer level, going to the level of DSO, so the local grid, to the transnational grids, so the distribution transmission system level. Key is to have standard solution at every level and to have possibility of data interchange to build synergy among the levels. This is addressed in several projects. Please click one time. The TSO are doing their work within the association and TSOE and developing their concept of TSO platform. So that's how this top level is addressed. When you go at the DSO level, now next click, please. We have the two projects are currently looking at those interactions. So the two green arrows, one is interface, one is coordinate. These projects are really developing a variety of use cases to deal with this data exchange at the level mentioned by these two arrows. Then going further, when you focus simply on the DSO level, click please on the next step. Two projects, Platone already mentioned, a universal, and looking at building this overall arching solution for DSOs, and clicking one more time at the customer level, the project Interconnect is developing standard that specifically are at home premises, basically. Clicking one more time, the project that is now putting all together, I would say, on one hand, the Bridge project is the activity of the European Commission for cooperation among different projects, similar to what OpenDI is doing. But the new project is now starting in fall, to be precise, just started 3 days ago, called OneNet, and will bring all this, let's say, family of project into a single view and creating the infrastructure and the condition for a single market of energy based on standard API and standard platform. And if you look at the description of OneNet, the way this interchange and harmonization will be done will start mostly from the FIWARE architecture. Going to the next slide. Yeah, this is just one slide on what OneNet is about. Started 3 days ago, the 1st of October 2020. I have the pleasure to be the coordinator in my role as part of the Fraunhofer FIT, the biggest research center on IT in Germany, which is in partnership with RWTH Aachen, so my university, coordinating this project with the idea to define a common market for Europe at every level, and then the corresponding IT architecture, basically bringing together this interchange of data is reported in the previous slide. Everything will be demonstrated in very large setting. We're talking about involving something like 20 countries in Europe and running demos in a variety of situations all across Europe, from Norway to basically Cyprus. So everybody is somehow involved and affected by this project. Next slide, please. And I would like now to give, finally, for the last two slides, the word back to my assistant, Markus Mirz, because in these two slides, we bring together several of the different aspects of platform in a single view that we now consider our own view in my institute. Please, Markus.
Yeah, this is showing the details of the platform that we have built so far. You can see 3 groups of projects that are integrated in this platform. First, the real-time simulation, which is a way either, for example, for researchers to build their own grid, which they can interact in real time with algorithms, hardware, or you could extend an existing grid using power amplifiers, or just connect devices to the real-time simulation using power amplifiers. Then we are also working on some IoT devices, low-cost IoT devices like our low-cost PMU, which was already used in field tests in the project Sonio. And the third part is what you expect from a DSO platform. This has the different services that could be useful for the DSO to run either on the real grid, or if you're a researcher, on the real-time simulation. So this is a modular platform that you can put together depending on your scenario. So you might not always use all of the components. Can you go to the next slide, please? Yeah, this is again showing bridging between the domains. So what we have already used is this is the message broker as a common bus between the FIWARE solutions that Malileh described and our microservices-based platform. But since you cannot leverage on the context broker API that FIWARE is pushing, so you don't have access to all the functions of the context broker, we are also developing this Go FIWARE connector that implements the API of the context broker. And that's it, I guess. Can you go to the next slide, to the final slide? Yeah, okay. That's all. Thank you.
Well, I wanted to thank you all, Professor Monti, Malileh, and Markus, for this overview, quite dense. A lot of, I would say, interesting tips and ideas. I would like to open now a Q&A session. So if you go back to the Menti pages, you can enter your questions. I will give you a few seconds to somehow break the ice and I will distribute or ask the speakers, our honored guests, to provide us with their view on your question.
I can see the first question: how ready is the energy industry technologically ready for this new category of prosumers? I think it's hard to give a single answer. I mean, my experience working in this variety of projects, you saw there is a variety of background in the different companies. So there are some, and I won't mention any name, not to be positive or negative about anybody, but there are utilities, grid operators that are extremely advanced and they deal with this technology with no problem. There are others that are vice versa struggling to get into this new world, and they will need much more support. And that's why we have been coming with this idea of service-oriented, because it will release part of the stress or the digitalization from the company itself.
Yeah, Professor Monti, there is another one that
there are
possibly, the one on blockchain. The one on blockchain and security, I think it's something that could definitely be seen you as someone able to give us good tips. So I will read the question: how FIWARE work with blockchain technology and to achieve security?
We never use FIWARE with blockchain, but we have been integrating blockchain in the other platform we have been dealing with. So the integration is technically feasible. And in the project Platone, we interconnect all the final customers through a blockchain architecture and making this blockchain extremely lean. This has been one of the main novelty of the project Platone in that direction. So that removes some of the concern about blockchain. So in principle, I don't know if Markus wants to do anything, as we were able to do it in the architecture that we have internally used on MQTT broker. That should be possible also in the FIWARE architecture. And particularly one of the companies involved, FIWARE seriously, like engineering, has also a lot of experience in the blockchain, and I'm sure that they have a solution to do this. So it doesn't seem to be, for me, a major roadblock.
I can confirm that there is a Horizon 2020 project in which engineering is one of the, I would say, main contributors. Sophie, correct. And for that specific project, DLT has been used to manage the integration of, I would say, different service providers' services towards users, and in this case, the use case was related to electrical vehicle charging. So I will provide you with some addresses at the end that you can use to reach us. And if there is any particular interest in this topic, we can try to connect you to the right people. I see that there is another question.
There are 4 questions. So can I, as a city, contribute, and what is my benefit? Well, my message would be, I think there is the interest for every city to become a smart city, so to get into a more digital world. What we have been seeing here is a way that this can be developed in a way that can cover the different verticals. So smart city is not only about providing new fancy services to the citizens, but it's really to bring the different sectors together. And that's where really I think is one of the strengths of FIWARE. We have been trying to show how solutions specifically developed with energy can be integrated into a bigger picture of a smart city. I think these are the relevant examples. what is nice as a city to go for open source solutions is also that you don't get stuck into a single vendor concept, but we are an open solution. More companies can contribute. You can move to one company to another, to one provider, and shift your weight during the time, so that you don't get into a single lock-in, vendor lock-in type of situation. This is roughly, quickly answering the question. But stream of video data, I don't have experience because we don't work with video. Do you know Markus anything, or Gianluca?
I haven't heard of any such application of FIWARE, no.
I do. There is a project, I think in the Netherlands, that we're leveraging also on video streams. And one of the biggest players in the past, and I'm saying in the past because then privacy concerns have been somehow hampering the possibility to use video streams, especially across Europe, was NEC, one of the, I would say, founding members of the FIWARE Foundation. And yeah, it has been done. And in general, stream data is something that FIWARE can handle.
There is a, okay, sure.
I don't know. Yeah, go ahead.
That's why I want, because it's a little bit annoying for everybody. What are the pros and cons of an open source financial model? We could do a full meeting on that one. I think it's a very tricky topic. I think one of the major value is that, as I was mentioning before, we create with something like FIWARE an open ecosystems so that different players can be integrated together in a single solution. This is, to me, a big value. Having an open source architecture, an open source API, doesn't mean that you don't integrate closed components. So at the end, when you look at the FIWARE, there are commercial version of FIWARE coming from major like engineering or Telefonica, and they can add components which are closed, and that's where more the business value is integrated. But what you have is an ecosystem that can talk to each other. This is the main value. Then obviously somebody has to run this as a, you say it correctly, as a mission critical, so that the service level agreement and so on is different from the problem of cost related to software development. So we have to separate these two aspects. I totally agree. But they are not in conflict, in my view, in this perspective. I'll try to answer quickly again. Other question, do you think we have the right technological framework to integrate local energy communities in our grids? Yes, technologically, sure. A little bit different is when we talk about legal framework and so on, because the Commission put the condition in the winter package. Now it's up to the different member states to create their own legislation, country by country. Obviously, they have to follow what comes from Brussels, but different version of interpretation and implementation in the single state, so member states, may bring different conditions more or less favorable for those energy communities to develop. But the trend is clear, and I don't think technologically speaking, there are major roadblocks. It's so far been mostly the legislation part that's been lagging a little bit behind. And look at technology, for example, we, in another project that we didn't discuss here, Interflex, we made a full city, small town, I should say, in Sweden, a separate community that could also isolate from the grid. It worked perfectly. From a technology perspective, it was no problem. We're working on making the system more efficient, more integrated, more everything, but they run, and they can be actually even better than the old structure systems.
We have a last one, if, sorry to interrupt you, because we need to also be wrapping up. And I assume that this question is somehow addressing you and your team again, Professor Monti. And so are any of your implementation dealing with the scenario of having a data marketplace that can handle third-party data providers and third-party application developers?
No one of those that we covered here. I would say they were dealing with the data marketplace, but we have other projects, some running right now that are dealing with data marketplace. We have a project just recently starting called Big Data for Energy, in which we build data marketplace specifically. And again, this will refer to a FIWARE architecture all in all. So the answer is need. We don't have it ready right now. It was not one of the examples here, but it's definitely something we are working on.
I think that Sophie, once again, the project we were mentioning before, has some third-party data sets being used.
The concept of data marketplace, that's slightly different. That's what I was pointing. So
yeah.
Integrating data from third parties is one thing that we have done it, but creating a marketplace of data is different, requires other elements like related to data sovereignty that we are working on, but they were not covering the project that we reported today.
Okay, then thank you very much. I think it was a nice ride, and I really appreciate you helping us at least building a picture of what could become topic or topics of future discussion. For sure, I would say this is just the beginning, and I hope that the next will be less messy or a bit less problematic from a technological perspective. And this is a mea culpa for the technical issues we had at the beginning. I will now ask Cem Zenturk to somehow give us some closing remarks before a couple of tips and next steps, words from my end. So, Cem?
Yes, love to. But before I start, I had to fulfill a wish of someone and ask you all for turning on the cameras so that I can make a screenshot if it's okay, so that we can push it through the social media. And yeah, it would be very cool. So just prepare the hairs and put on a t-shirt or something like this. And yes, it's filling. Some people are running away. It's also good. Yes, very cool. Some are remaining. Andreas, Conrado, Julia, Gustavo, Ken, Katarzyna. Sorry. Yes, very cool. Conrado and HP. Then we are full. Sven? Maybe Sven? No Sven? Okay. Then 3, 2, 1, cheese. Perfect. Thank you very much. So I have a lot. Then, yeah, to the closing remarks. So first of all, thank you everybody to attending today. And yeah, Gianluca, thank you very much for organizing and bringing all these people together. So we could listen to some very cool stuff, which is extremely new, very exciting and complex. So very proud to have so knowledgeable people in this community. So thank you very much at this point. Yeah, we, as you imagine, we are also very proud and happy to be a part of this great initiative. We absolutely believe that challenges in digitization and transformation of each area and each complexity can be solved together. So therefore, an open source culture is essential. Yeah, the target mode of operation and engagement in this IDEAS Forum is an open source culture. Open source culture, collaborate, cooperation, contribution will enable and empower our community so that we can all move forward together and transform our environment, our ecosystem to a better place. And starting as a small light together, we can become a huge and brighter light and lighten up the world. So for this reason, we, as you imagine, decided to join and contribute to this initiative to IDEAS Forum. And we will work, contribute, and raise our knowledge together with you and support this community. So, and we are really looking forward to get engaged, talk, and exchange about all this exciting stuff, like we listened today, and support altogether this community. Looking into the following weeks and months, I guess Gianluca will take over and give us some overview and some insights what we can stay tuned. So thank you very much.
Well, thank you, Cem, and thank you, Meijin, for having contributed together with RVTA and a few others to the build-up of this initiative. As I mentioned, today was the first chat on our stream related to digital energy or smart energy, whatever you want to call it. Professor Monti stressed the importance of data models when looking at building these applications. So it's not just the APIs that are winning the game. For sure, we need to be sure that we are using sure that information we are exchanging are understood by system or between systems in the right way. So on October 21st, again, Mali will somehow guide us through Sargon. Sargon is an extension, but I don't want to tell you anything. So this is definitely something interesting that is adding on top of the traditional approach when talking about data models. And the traditional approach is somehow represented by, I would say, the extremely solid infrastructure built on SIM, which will be the subject of a tech bill that Markus Mirz will provide us on October 28th. And after this, we will also have some more events related to data models between, I would say, the beginning of November and mid-January, with some other presentations in December on specific case studies. We have already started also promoting some of the initiatives that are related to the work that we are planning to do and hoping to do for smart cities. So on October 29th, there will be a very interesting presentation that whomever of you is involved in smart mobility, particularly mobility related also to electrical vehicle charging infrastructure, should be attending. And we will have 2 testimonials. The event will be in German, but it will be addressing 2 different philosophies, not that different, but 2 philosophies from different countries on addressing mobility topics, and in particular what is being done in Florence in Italy and in Wolfsburg here in Germany. And then on November 5th, we will have somehow a pitch from the FIWARE Foundation, from Alberto Beia, the chief data architect at the FIWARE Foundation, on the work the foundation has been doing in supporting the development of smart data models. With this, Next, please. I think I can only but thank you for joining us and being with us today. For sure, we are hoping that you will be considering supporting us and participating in our initiatives. Next, please. So get in touch with us. There are different ways. You can send us email through our website and the forms on our website, or send us private messages through our Facebook, Twitter, or LinkedIn pages. If you have any specific questions on the topic we've been addressing today, use the same channels, and we will try to put you in touch with the people in our technical domain expert team, and try to help you as much as we can. Once again, thank you, everybody, and stay tuned, and hope to see you when we will be talking about Sargon on the 21st of October. Thank you.
Bye, everyone. Thanks.
Bye-bye.
Bye.
Thank you. Bye-bye.